Okay, so this problem is a classic. You're climbing stairs, 1 or 2 steps at a time, and you need to count all the distinct ways to reach the top. Here's the key insight that blows people's minds. To reach step N, you either came from step N1 or step N2. That means the number of ways to reach step N is just the sum of the ways to reach those 2 previous steps. Sound familiar? That's literally the Fibonacci sequence. Once you see that, the whole problem becomes trivial. First things first, we handle the tiny cases. If N is 1, there's exactly 1 way to climb, just take 1 step. If N is 2, there are exactly 2 ways, take 2 singles, or 1 double. And conveniently, both of these just return N itself. Super simple, right? This also protects us from edge cases before we enter our main logic. Here's where it gets interesting. Instead of storing an entire array of results, we only keep track of 2 variables, A and B. Think of A as the number of ways to reach the previous step, and B as the ways to reach the previous step. We set A to 1 and B to 2, representing the answers for step 1 and step 2 respectively. This is our launching pad for building up to step N. Now we loop starting from step 3 all the way up to step N. Why step 3? Because we already know the answers for steps 1 and 2, those are our base cases stored in A and B. Each iteration of this loop computes the answer for the next step up. We're building the solution from the ground floor, 1 step at a time, pun totally intended. Watch what happens here. This single line does all the heavy lifting. We simultaneously update A and B using Python's tuple assignment. The new A becomes the old B, and the new B becomes A plus B, which is the answer for the current step. It's like a sliding window of size 2 moving up the staircase. No extra array needed, just 2 variables leapfrogging forward each iteration. After the loop finishes, B holds the number of distinct ways to climb exactly N steps. That's it, we just return B. By the time we exit the loop, B has accumulated the answer for step N through all those additions we did along the way. Clean, elegant, done. Let's talk complexity. Time is O of N because we loop from 3 to N, just a single pass. Space is O of 1 constant because we only ever store 2 variables regardless of how big N gets. The big takeaway here? Whenever a problem asks you to count ways and the current answer depends on previous answers, think dynamic programming. And if you only need the last couple of values, ditch the array and just use variables. Fibonacci thinking saves the day.